Yo, it's Miss Baldwin, and welcome to Trendy Friday. That's right, we're going to turn up like we always do because this is our special day. So, of course, I'm not there, but I miss you guys so much, and we're going to conduct class just like we normally do, but a little different. I'm on the screen, and you're in class, but we're going to make it work. All right. Let's start with our class creed on the count of 3. 1, 2, 3. Yes, I will learn today. I will do my best. I will give it all I've got to ensure my success. I am smart. I am bright. I can do anything. I'm an excellent student. And you know what that means. I work hard. I study. And my learning prevails. And when I am tested, I will pass the chemistry SOL. Woo! Ah! Hopefully, you said that turned up just like me. So you should have some papers that the substitute is giving you to look like this, and you should also have your box. But if you don't, I'm going to give you time to do that. So you need 3 things. You need your papers, you're going to need your box for your interactive notebooks, and you're going to need your notebook. I'm going to give you 1 minute to get it and get back in your seat. Time starts now. Okay, so that wasn't a minute, but I'm pretty sure you already have everything you need. So I want you to turn in your notebooks to page 55. There shouldn't be anything on page 55 and 56. And this paper that looks like this, do you see it? All right, I want periodic trend 1, atomic radii, to go on 55, and I want periodic trend 3, let's go like this, electron affinity, to go on page 56. So this side goes on page 55 and this side goes on page 56. I'm going to give you 1 minute to cut it out and glue it in. Time starts now. Even Miss Baldwin's going to cut it out. Let's see if I can do it in a minute. Can I do it? I think so. All right, so you should have glued in periodic trend 1, looks like this, on page, can you see it? Sorry, on page 55, and periodic trend 3, looks like this, on page 56. All right, now on yesterday we talked about our periodic table, and it is amazing. We love it, we need it, we embrace it, okay? Now today we're going to talk about trends. We're going to talk about patterns that happen as we read our periodic table from left to right. And we have 4 of them. How many? 4. 1, 2, 3, 4. The first trend is atomic radii. It deals with the size of the atom. The second trend is ionization energy. The third trend is going to be electron affinity, and the fourth trend is going to be electronegativity. So here's what I want you to do. I want you to take out your periodic table, and I'm going to take out 1 too. Now mine may look a little different from yours, but we're going to make it work. Mine looks like this. Now do you see these 2 big arrows? You don't have that on yours. I want you to draw an arrow going from left to right and an arrow going down. Okay, so I'm going to let you see how it looks. An arrow going from left to right and an arrow going down. Yours doesn't have it. So arrow going left to right, and kind of make it big and leave space so that you can write on top of the arrow. We're going to label our periodic table with our trends. So above the arrow, as we go through our trends, I want you to write down what happens as we go from left to right. Now for this next part, I'm going to need to move over there. Do you want to walk me to the board? Of course you do. All right, so we're going over here to our board. Can you see me? Can you see the board? Can you see the board? Yes, you can. To our first periodic trend. Can you see it? It's called atomic radii. It deals with the radius of an atom. Now, there's a lot of words on this slide, and I don't really want you to get too concerned or confused with that. But what I do want you to do is above your arrow on your periodic table, I want you to write atomic radius increases. So you're going to write, and if you want to abbreviate with AR, you can. You're going to write atomic radius and an up arrow. You're going to write atomic radius and a down arrow. Okay? Can you see what I've written? Atomic radius and a down arrow. So as we go from left to right, the atomic size decreases. Now as we go from top to bottom, over your down arrow, you're going to write atomic radius increases. Okay? Atomic radius increases. Now on the board, you'll see some atoms. Okay? And if you'll notice that as we go from left to right, these radiuses get smaller. But as we go from top to bottom, they get larger. Now, why? Why? Why do you think as we go from left to right it gets smaller and from top to bottom it gets larger? Well, that's right. It deals with electrons. I tell you, we just can't get enough of those. We talked about protons, we talked about isotopes and neutrons, and now comes the big kahuna, electrons. All right? Now, as we go from top to bottom, there are more rings or more shells of electrons. So each row adds a new ring, which means that as we move from top to bottom, we have more rings, and thus the atom is going to be larger. But as we go from left to right, we aren't adding rings. We're only adding electrons. Well, it deals with something we call electronegativity, and we'll talk about that in just a second. But all you need to know is that the atoms, as we move from left to right, really, 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 really like electrons. So much so that even though the electron number is going up, the atom wants to keep the electrons closer. So fluorine really has a thing for electrons. So it is going to suck those electrons very, 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 very close to the nucleus, thus making the atom smaller. Hydrogen or lithium, however, doesn't really have a thing for electrons, so wherever they are, it's just as cool with lithium. So as we go from left to right, the atomic radius decreases. As we go from top to bottom, it increases. Now it's time for you to do it. Here we go. I'm going to move along. You do it. Can you see it? Can you see it? I'm going to give you some time. I want you to pause this screen, and I want you to put the first row in order from largest to smallest. The second row in order from largest to smallest, and the third row in order from smallest to largest. And time starts now. Have y'all paused the video? Pause the video. Okay, we're back. Now, hopefully, you have put those in order. So let's check and see if you are correct. Between SE, S, O, and TE. To put it in order, what did you have? If you went from smallest to largest, which is what I told you. Did I tell you smallest to largest? Or did I say largest to smallest? Well, no matter. We'll talk about it. All right. Here are the answers. For the first row, we went from largest to smallest. So the largest one is going to be TE, then SE, then S, and then O, going from largest to smallest. Remember, as we go from top to bottom, the one on the bottom is going to be the largest. So it should have been TE, SE, S, and O. Second row, largest to smallest. The largest one, they were all in the same row. So as we go across, it gets smaller. So the largest one would be the furthest to your left. So the largest one would be Si, then P for phosphorus, then S, and then Cl for chlorine. So row 2 should have been Si, P, S, and Cl for chlorine. Last one was a mixture. These guys are all over the place. So we had to go the opposite way, from smallest to largest. And the smallest, and which will always be the smallest, is going to be fluorine. So it should have been fluorine, then sulfur, then arsenic, and then gallium. Again, that's fluorine, sulfur, arsenic, and then gallium. I hope you got it right. Okay? So, on your periodic table, you can always remember atomic radius going across, it what? It decreases. And going from top to bottom, it increases. Trend 1, we out atomic radius. Now, the next trend is called ionization energy. Now, above your arrow, still right on the periodic table, I want you to write IE, and that's going to stand for ionization energy. Now, as we go across, ionization energy is going to let's see. It is going to increase. Ionization energy is going to increase. So here's what I've done. Over my arrow, I wrote IE increases, and I'm talking about left to right. Now from top to bottom, what is it going to do? IE is going to decrease. All right? IE, you see it, is going to decrease. All right? Now, we got a brand new trend. Welcome our brand new trend. Ionization energy. Now, here's my little spiel about ionization energy. What do I teach in this class? What do I teach? I teach concepts. Hopefully you said that. All right, the concept behind ionization energy is the energy it takes to remove an electron. All right? Now, a lot of elements don't want to remove their electron because they're trying to gain. Which elements are those? Right, the ones that are furthest to the right. Things like fluorine, chlorine, bromine. Hey, they don't want to lose an electron. They want to gain an electron because they're trying to be like a noble gas. So it's going to take a lot of energy. I don't think y'all understand. Y'all want to walk over to the periodic table? All right, let's do that. Over to our periodic table. Can you see it? Ah, yes. All right, so we're over here by fluorine. I'm going to try to hold this and do it. Chlorine wants to gain 1 to be like neon. So, guess what? It does not want to lose an electron. All right? However, we're going to walk all the way down here to lithium, which does want to lose an electron, so it doesn't take a lot of energy. It wants to do it. So the trend goes, as I go from left to right, the amount of energy it takes to take away an electron is going to increase because this guy does not want to lose an electron. So left to right, ionization energy decreases. Now, no, I'm sorry. From left to right, ionization energy increases. It increases because fluorine doesn't want to give an electron. All right, now, as I go from top to bottom, all right, we're going to come back over here to lithium. You see it? We're going to go all the way down. This guy down here, francium, he is huge. I mean, he has 7 shells and tons of electrons. So, the amount of energy it takes to remove an electron is not going to be much. He got so many electrons, he can't even keep track of them all. So, as we go top to bottom, ionization energy is going to decrease because those atoms are much, much, much larger. You got it? Trend 2, we in there, over and out. Watch the next video for trends 3 and 4. Bye.